9.3, solving quadratic equations using square roots. Okay, this may be one of the easier warm-ups you've had, but let's get going. You'll see why we're doing this as we get into the lesson. But go ahead and do the warm-up. So pause the video, go ahead and do them. Okay, hopefully you got these as your solutions. And probably as important as remembering how to do these, which obviously you could, probably could do them 3 years ago, is plugging back in to check. Just making sure you're doing that. That's going to be crucially important as you work through this lesson. Okay, our learning target is that you will know how to use the extracting the root method to solve quadratic equations in the form of ax squared plus c equals 0. So again, this is the third of 5 methods that we're learning to solve quadratic equations. The first was by factoring and using the zero product property. That was one. Second one was from 9.2, which was by graphing. Not our favorite method, but set your equation equal to 0 and then find the x-intercepts. And then this is the third. We call this extracting the root. Okay? All right, so you're not going to probably work with a partner, but if you have someone around that wants to do it, awesome. Feel free to use Desmos. So go ahead and go onto Big Ideas and pull up Desmos using the math tools. You know where to find that by now. If not, oh boy. Okay, use Desmos to solve each equation by graphing. Explain how the number of solutions of ax squared plus c equals 0, each of these will be in that form, relates to the graph of y equals ax squared plus c. So I'll do the first one with you. Okay, so hopefully you went and you graphed on Desmos, and you would have gotten this. Okay, what do we know? Well, that would be the same as graphing this, right? That's what you would have done. And what do we see? I see an x-axis here. Oh yeah, any x-intercepts are going to be solutions. So I have 2 x-intercepts, which means I have 2 solutions, and those are -2 and 2. Again, if you go back to the original and plug back in, -2 quantity squared is 4 minus 4 is 0, and 2 squared is 4, 4 minus 4 is 0, check, check. Okay, so go ahead and do the others. You may even be able to look at these equations and kind of get a sense of how many there might be. But go ahead and give them a shot. Pause the video, try them, take your time, you got this. Okay, so on B, you probably noticed that there are no x-intercepts, right? Because from this thing, we know that our y-intercept is at 5, and we know our axis of symmetry would also be on the y-axis, right? If you think about this, if this is in standard form, b would be plus 0x, so it would be 0, and obviously 0 divided negative parentheses 0, or negative, then 0 over 2 times 1 for negative b over 2a is equal to 0. So doesn't cross the x-axis is the important thing, no x-intercepts. Okay, you probably could look at this one and see what the answer is going to be, but hopefully you graphed it. And yeah, you got the parent function, didn't you? Because x squared equals 0 is like graphing y equals x squared. So you have one solution because we have one x-intercept, and that is 0. Okay. Well, you hopefully can see where our vertex is going to be on this one. Yep, down at 0, -5. And it opens up, obviously, because a is 1. So when we graphed it, we got 2 x-intercepts, and those are at the square root of 5 and the negative square root of 5. So plus or minus square root of 5, which is about plus or minus 2.2. Okay. All right, so I want you to complete each table. Use the completed tables to estimate the solution of x squared minus 5 equals 0. Okay. And if you think about this, you hopefully can visualize what this graph would look like and where the vertex would be, and see that there are going to be 2 solutions. Okay. So I'll go ahead and start you off here. So basically what we're doing is we're plugging in this value for x, the ones listed here, using a calculator, of course, 2.21, and we're plugging that in for x over here. So 2.21 quantity squared, you would do that on your calculator, and then you would subtract 5, and we get negative 0.1159. Okay? And then why don't you go ahead and continue on, and then let's see what that means. So we got that, and then go ahead and do it over here for these. Try all those, and then pause the video, and then try them, and then you can see I've rounded to 4 decimal places, the nearest 10,000. Did the same thing here. So what is this telling us? Well, what do we think the solution would be around? Well, notice here that the value at 2.23, or negative 2.23, and notice those are the same, right? Because when we square it, it would be in parentheses when we plug in, and we would get a positive number. Goes from a negative when we subtract 5 to a positive when we plug in 2.24, or negative 2.24. So we know that the x-intercepts are going to be when x is between those two, right? So we would have 2 x-intercepts, and it's at about plus or minus 2.24. It's a little bit less, but definitely more than 2.23 or negative 2.23, because this value is the closest to 0 of all of these, right? This one would be second closest, third closest, fourth closest, fifth closest, sixth closest, and obviously same numbers over here. Okay. Okay. 2 equations are equivalent when they have the same solutions. A, are the equations x squared minus 5 equals 0 and x squared equals 5 equivalent? Explain your reasoning. Okay, go ahead and do that. Yeah, of course they are, right? The first one, if you added 5 to both sides, you get the second one, right? We followed the golden rule of equations. So yeah, duh, of course they are. Okay, B, use the square root key on a calculator to estimate the solutions of x squared minus 5 equals 0. So in other words, what you're going to do is when you add 5 and take the square root of both sides, right? Because if x squared is equal to 5, then shouldn't their square roots also be equal? And when you do that, notice what we got. We got approximately 2.23. So, that's pretty darn similar to what we got over here, right? And we said it would be a little bit more than this, right? Or a little bit less than negative 2.23, right? So kind of between those two and between those two. And that's exactly what we got here, okay? So that's an approximation, right? Because we're taking the square root of something that's not a perfect square. You've heard me talk about how that's an irrational number, which means that it goes on forever and doesn't repeat in a pattern that we can discern or figure out, kind of like pi. So the exact solutions to this would actually be just plus or minus the square root of 5. That's an exact number. We don't know exactly what the square root of 5 is, or the negative square root of 5, but we know that it's approximately this number or the negative of this number, okay? But this is the exact way of writing it. So it depends on the problem. If we ask you to estimate, then you would, want to take the square root of 5 and round it to the nearest number of decimal points that we mentioned. If we say exact solutions, then we're talking about this. And if we don't say anything, then, that's our fault. Neither one will be fine. So don't sweat it. Okay, so here we go. So if we have something that's in the form of x squared equals d, where d is greater than 0, then we're going to have 2 real solutions, okay? So example, this would be x squared equals 9. Well, if x squared equals 9, then that means the square root of x squared is equal to the square root of 9, and we know the real solutions or real roots of 9 are 3 and negative 3, so plus or minus 3. So there'd be 2 solutions, okay? When d is 0, so if we had x squared equals 0, well, what's the square root of 0? Just 0. That's the only one. There's no such thing as the opposite of 0. And if d is a negative number, then we're basically saying, okay, let's use negative 4. X squared equals negative 4. If we take the square root of both sides, we can take the square root of x squared and get x. But can we take the square root of a negative? No, remember that's like an imaginary number or not a real root. So there would be no solution to that, or no real solutions. Okay, when you get into algebra 2, you'll learn a lot more about imaginary numbers and so forth. Okay. All right, so let's go about doing this. Let's solve 3x squared minus 27 equals 0 using square roots. So why don't you go ahead and try it. See if you can get it. If you can't, that's okay. We'll follow along. There's lots of examples here. So, all right. So go ahead and pause if you like, or just keep following along, taking notes. Okay, so first thing I want to do is I want to get that x squared by itself. So I'm going to add 27. I'm going to divide both sides by 3. So I get x squared equals 27 over 3, which is 9. If those are equal to each other, then their square roots are equal. So I can take the square root of both sides. We can say we root both sides. So I have the square root of x squared equals the square root of 9. We know the square root of x squared is equal to x, right? And what's the square root of 9? Plus or minus 3. Okay. Check our answers. 3 or negative 3, when I plug it in, I'm going to use parentheses. Either way, when I square it, I get 9. Times 3 is 27. Minus 27 equals 0. Check, check. Simple as that. Okay, try this one. Go ahead and pause. Okay, I'm back. So I'm going to get that x squared by itself. So I'm going to add, and I know from the previous page when we went over the rules that when I take the square root of both sides, I'm basically taking the square root of 0, which is just 0. So we just have one solution. And if you plug in here, 0 squared is 0. 0 minus 10 is negative 10. Does that equal negative 10? Yes, it does. Check, check. Okay, try the next one on your own. So hopefully you went ahead and subtracted 11 from both sides, divided by negative 5, and got x squared equals negative 1. Okay, we're going to take the square root of both sides. Uh-oh. Square root of a negative? I don't think so. No real solutions. And if you're wondering, like, well, why not? Why can't we take the square root of a negative? At this point in time, you can't, because think about it. Remember, what a square root is asking is what number multiplied by itself will get us the radicand, the number under the radical sign. Can you multiply a negative times a negative and get a negative? No. Can you multiply a positive times a positive and get a negative? No. Can you multiply 0 times 0 and get a negative? No. In other words, it's impossible. So it's no real solution. Okay. This next one's a little interesting. You may be thinking, well, what if I square the binomial on the left side and get x squared minus 2x plus 1 equals 25? And then, yeah, we might be able to put that into standard form and then try and factor it. But we're trying to do this by using square roots. So I want to show you another method. This side is equal to this side, right? Which means their square roots would be equal. So let's take the square root of both sides. Well, what's the square root of something squared? It's just going to be x minus 1. And what's the square root of 25? Plus or minus 5, right? Okay. And this is where we get to play. I think we played this earlier this year. It's back. The cover-up game. Oh, yeah. Here we go. So what we're going to do first, we got to get x by itself. So, I jumped the gun. I'm so excited to play the cover-up game. So first thing we have to do is get x by itself. So let's add 1 to both sides. So we have 1 plus or minus 5. Or you might have written it as plus or minus 5 plus 1. Doesn't really make a difference, commutative property. You then literally get to play America's favorite game. You literally get to cover up one of the signs. So let's cover up the positive and go 1 minus 5. Okay, that would be negative 4. So that's one of our solutions, we hope. And then cover up the negative, and 1 plus 5 is 6, and that's our other solution. And then we would check them, right? So let's check with the negative 4. Negative 4 minus 1 is in parentheses, so we have to do that first. That's negative 5. It's still in parentheses. Squared makes positive 25. Well, obviously the square root of 25 equals the square root of 25. And if I plug in 6, 6 minus 1 is 5. 5 squared is 25, so it's the square root of 25 equals square root of 25. Check, check. Okay? So you really want to focus on how am I going to be able to take the square root and get just an x out of it. All right, go ahead and try this next one. So hopefully the first thing you did was add 15, divide by 4, and here we are at x squared equals 0. If you take the square root of both sides, the square root of 0 is 0, and we have x equals 0. That's the only solution. All right, go ahead and keep practicing these. Okay, so these are just more examples of similar, but I strongly suggest getting this. If you can do all these, you're really on top of the game. And just think, 9.2 wasn't that bad with the graphing. You get this, that's everything that's going to be on the quiz. That covers 9.2 and 9.3. Remember 9.1, where we've done that. That was back in chapter 6. We're not going to, purposely test that material. It might come up in some of this, but that's how math works. Okay, so what are you going to do first? Hopefully you subtracted 12. You have x squared equals negative 2. Well, you hopefully can stop there, but if not, you probably take the square root of both sides and realize, oh, can't take the square root of a negative. That is no solution. Remember, 0 with the big slash through it means no solution. You could write no real solution. You could put actually empty Jay Leno's, set braces. You could do those if you wanted to. Okay. All right, let's try this one down here. Again, we're going to do this by using square roots. Notice that if it's already something squared, if we take the square root of both sides, we're going to be able to pull just a 2x plus 1 out of there. And square root of 36 is plus or minus 6. Oh yeah, it's coming, but not quite yet. That game's coming. We're going to obviously subtract 1. So negative 1 plus or minus 6, or plus or minus 6 minus 1. And then we're going to divide by 2. So we got that. And then play America's favorite cover-up game, or favorite game, the cover-up game. So cover up the positive. So we'd have negative 1 minus 6. That's negative 7 over 2. So negative 7 halves. And then cover up the negative and go with the positive. Negative 1 plus 6 is 5. 5 over 2 is our other solution. Let's check those. If I plug in negative 7 halves for x up here, the 2's would cancel, and I have negative 7 plus 1 in parentheses squared. Negative 7 plus 1 is negative 6. Negative 6 quantity squared is 36. 5 over 2, if we plug that one in, the 2's cancel. 5 plus 1 is 6. 6 squared is 36. Check, check. Okay. Try this next one. Actually, multiple ways of doing this one, but give it a shot, and then I'll kind of go through both. Okay, so what I did was I divided by 4 first to kind of get my squared binomial by itself. I then took the square root. The square root of 9 over 4, as we learned in section 9.1 back a few months ago. We can go ahead and split that if we like. Make it square root of 9 over square root of 4, which becomes plus or minus 3 over 2. Square root of 9 is 3, square root of 4 is 2. Yep, it's coming. Add 3 and play the game. So 3 plus or minus 3 halves. So 3 plus 3 halves would be what? 4.5. And 3 minus 3 halves, which is like 1.5, right, would be 1.5. So our answers are 3 halves, which is 1.5, and 4.5, or 9 halves. And again, I'm not going to take the time right here, right now to check these, but if you plug these in, they would work. Another way I mentioned is if we had just taken the square root from here, this would have worked. We would have had square root of 4 would have been 2, so we would have had a 2 here. Square root of 9 would have been plus or minus 3. We then would have done what? Divided by 2, and all of a sudden we would have had x minus 3 equals plus or minus the 3 over 2. So that would have worked as well. But generally people like to get the squared term that involves the x, either as the binomial squared or just the x squared by itself. Okay, so let's solve using square roots again. And now they're asking you actually to basically round the solutions to the nearest hundredth. So if it's the square root of a non-perfect square, they want you to use a calculator and round to the nearest hundredth, which is how many decimal places? 2. Good. Okay, so go ahead and give that a shot. So hopefully you added 13, you divided both sides by 4, you took the square root of x squared, you took the square root of 7, and you ended up getting x equals plus or minus root 7. And then use your calculator, and you got approximately 2.65 plus or minus. Okay, next one, subtract 8. We get x squared equals 11, square root of both sides, square root of 11 plus or minus x equals square root of 11 plus or minus the square root of 11, excuse me. And what should that come out to be? Well, I know 3 squared is 9, 4 squared is 16, so it's going to be 3 something. And our calculator tells us when we round it to the nearest hundredth, it's plus or minus 3.32. And I think we've seen this before, but the squiggly equal sign means approximately. All right. So go ahead and try these. Added 2, divided by 5, square root of those. So you can split it if you like. Why would we be splitting it here? Can I leave my answer like that? By the way, it does sound round to the nearest hundredth, so we are eventually going to figure that out. But if it had been to find the exact one where we wouldn't, would we leave our answer in this form? I hope you said no, because this is not simple rad form. You can't have a radical in the denominator. Remember that? So we would multiply by root 5 over root 5. Root 2 times root 5 we can write as root 10. That's fine. And what's root 5 times root 5 on the denominator? 5. So we have root 10 over root 5. Remember, outies with outies, innies with innies, so we can't cancel those. And now we can go ahead and do our approximation. So you take the square root of 10 and then divide it by 5. And we can do the same thing with the negative, but we know it'll come out the same. And rounded to the nearest hundredth, I got plus or minus 0.63. Okay, this one, we're going to add 30, divide by 3. Similar problem to what's up above. So what are we going to do next? Well, we're ready now to take the square root to get x, right? So do that. And if we want to leave it like that, I know what you're saying. Well, couldn't I just take the square root of 34 and, oh, by the way, what's missing here? Hope you said the plus or minus. Yeah. Could I take the square root of 34 and then just divide it by the square root of 3 on my calculator? Yeah, you could. But I'm just showing you this in case it's a problem where we don't ask you to round. Up top, we know the square root of 34 times the square root of 3 is, we can't break that down. There's no perfect square factors in it. So we get the square root of 102. And then we could take the square root of that divided by 3 on our calculator and get plus or minus 3.37. Okay, a little word problem. A touch tank. Ooh, love touch tanks. Pacific Aquarium in Long Beach has an awesome one. Okay, a touch tank has a height of 3 feet. Its length is 3 times its width. The volume of the tank is 270 cubic feet. Find the length and width of the tank. So right now, as I'm processing that, I'm going to go back and read it again. Touch tank is a height of 3 feet. Its length is 3 times its width. The volume of the tank is 270 cubic feet. Find the length and width of the tank. Well, okay, volume. So I'm immediately thinking length times width times height. And they gave us the height, and we know the length compared to the length is 3 times the width. 3 times the width. So again, thinking formulas, so I'm thinking length times width times height equals volume. And what would make the most sense for our variable to represent? I think most people in this case would say the width, because the length is 3 times that. So I went ahead and made the width what x is. And you could use w, obviously, if you wanted to. Well, if x is the width and the length is 3 times the width, how would we represent the length in terms of x? Yeah, we would say 3x, right? So we could do that. Now, if you made x the length, then what would the width have been? X over 3, exactly. Okay. So then what's our formula here? Well, we know the height is 3. We know the width can be represented by x and the length by 3x. So what are we going to do? Oh, and we also know what other important information. We know the volume's 270 in cubic feet. So we can multiply 3x times 3, which simplifies on the left side to 9x squared. We can do what now? Don't have to, but probably most of you are saying divide by 9 to just get x squared by itself, and that's totally fine. Notice 9 is a perfect square number, so it wouldn't be the worst thing in the world just to take the square root of 9x squared and get 3x. So, but anyway, I divided by 9, so x squared equals 30. Take the square root of both sides. So x equals, is there a perfect square factor I can pull out of 30? No. So it's about 5.48. That's what x is. Okay, so now we need to answer the question. Find the length and width of the tank. So the width's going to be what? 5.48. And the length would just be 3 times that. And 3 times that is going to be what? A little less than 17, between 16 and 17. Yeah, came out to about 6.44. Notice in this problem, I did not say what to round to. I just rounded to the nearest hundredth. I think that's probably a good default if we, say, don't say to round to the nearest hundredth, but I wouldn't take off if you rounded somewhere else. And then our check, right? We want to multiply this times 3. And if you do that, you get 270.27. Now, why do you think we got something that was a little bit more than 270? Had to do with the rounding and taking the square roots. But obviously, we're pretty darn close, so we know we did it right. Okay, great. All right, so here's a yield sign. You've seen these before. And you'll learn all about those as you guys start getting ready, probably within the year for most of you, to start taking those online classes for driver's ed. Start getting that permit. Don't want to wait on that. Anyway, the area A of an equilateral triangle with side length S, notice S, 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 right? Because it's an equilateral triangle. All sides have the same length. Is given by the formula area equals square root of 3 over 4 s squared. And when you get to geometry, particularly those of you that take honors geometry, you'll actually prove why this is the case. I think probably everybody will do it. But that is an actual formula. If you don't trust me, go ask the honors geometry students. They'll tell you they know it. Okay. Solve the formula for S, then approximate the side length of the traffic sign that has an area of 390 square inches. So there's 2 parts to this. First, we need to solve for S just with the formula here. So we need to get S by itself. So what are we going to do? All right, give it a shot. Okay, we're back. So obviously we want to get S squared by itself. And if it's being multiplied by root 3 over 4, we want to multiply by the reciprocal to both sides. Yay, the reciprocal, we love it. The root 3's would cancel, the 4's would cancel, and we're just left with S squared on that side. And obviously on the right side, we'd have, because it's A over 1, we could write it as 4A over root 3. All right, now what do? We want to get S. We don't want S squared, right? So we need to take the square root of both sides. And I know this is going to seem strange, but we're taking the square root of something that has a radical in it already, aren't we? Yeah, that's weird. Okay. All right. So have we now solved for S? Yeah, we have. Now, the second part says to approximate the side length, S, if the sign has an area of 390 square inches. So remember, area is right there, so we just plug in a 390, and can multiply that out. 4 times 390 is 1560, and then we could divide that by root 3, and then take the square root of that, and we end up getting plus or minus 30.01. So are there 2 answers to that? No, of course not. You can't have a side length that's negative. So our answer is about 30.01 inches. And it could be with the rounding that it's actually exactly 30. I'm not sure. Okay, good. All right. What would you do if the volume of the tank, and again, we're back to this problem here, the touch tank, if the volume was 315 instead. Well, similar type problem, right? Except we have 315 instead of 270. So, because they haven't told us any other changes, right? So we'd still have 3 times x times 3x for the length, the width times height multiplied together. This time it's equal to 315. And then if we divide by 9, we get 35. X squared equals 35. Take the square root of both sides. And you can approximate it. And then, so obviously the width would be what x is. So about 5.92 feet. And the length would be about 3 times that, or just a little less than 18. Okay, another problem here. Surface area of a sphere. Cool. Another thing that you'll learn in geometry next year. Or just a few months down the road, isn't it? Awesome. Although that's something you'll probably get to at the end of geometry. So anyway, the formula is the surface area of a sphere with radius r is s equals 4 pi r squared. So we want to solve the formula for r, and then once we've done that, we're going to find the radius of a globe with a surface area of 804 square inches. So again, 2 parts. Let's do the solving for r first. So from this formula, we'd obviously want to divide both sides by 4 pi. So we get s over 4 pi equals r squared. Yep, you're going to take the square root of both sides. Okay. Okay, the right side, we would have r. On the left side, I can take the square root of 4, right? Remember, I can always split this into square root of 4, square root of pi. So square root of 4 becomes 2. So we have plus or minus square root of s 2 over root pi. Not crazy about having that root pi down below, right? So we want to multiply by root pi over root pi. Get rid of the radical in the denominator. And what would we have? We'd have square root of s pi is s times pi over 2, and then root pi times root pi makes a pi. Lots of pi. Okay, and that's equal to r. And then to do the second part, that's the easy part, right? We're just going to plug in 804 for what? Hopefully you said s, because s is the surface area. And we would go from there, and we get plus or minus 8, approximately, rounds to that. So that's our radius, about 8 inches. All right, your exit ticket is to state the number of solutions for each equation. So think about how you would go about doing that. Give it a shot. Okay, well, hopefully for this one, you got 2. And for this one, you got 0. And for this one, you got 1. How do we do those? Well, let's do it by extracting the root. You would do what? You would subtract 8 and get 32, divide by 2. So we'd have x squared equals 32 divided by 2, which is 16. Square root of x squared is x. Square root of 16 is 4. So, and negative 4. So there's our 2 roots. On this one, we would what? Add 8. So we'd have 2x squared equals negative 32. Divide by 2, we'd have x squared equals negative 16. Can you take the square root of a negative? Nope. No solution. And here, if you divide by 2, you get x squared equals 0. What's the square root of 0? Just 0. That's the end of it. Okay. Again, we'll take questions on this in class. And hopefully that explains extracting the roots. Have a nice day.